used to determine if they can prove something to be true or not. Scientific method, first step is the problem. The problem is the question being addressed. It could be something like, why is the sky blue? After you develop your problem, you're going to come up with your hypothesis. A hypothesis is a guess, it is what we think the answer to a problem might be. At this point, we don't know if the hypothesis is correct or not because we haven't done any testing. After your hypothesis, you're going to start with your procedure. Your procedure is a series of steps that you take to try to prove the hypothesis is correct. Scientists try to write very detailed procedures so that somebody who tries to repeat the experiment later on will be able to repeat it exactly and hopefully duplicate the results. It is not unusual to have run or change a procedure several times to get it written down specifically enough. After you write down your procedure, you're going to conduct with your data. The data is the information which is collected when the procedure is ran through. It could be a series of observations, such as noticing different colors in the sky at different times of a day. After you get your data, you're going to write down the results that you saw. This is where the data is grouped and organized into results, so it is easier to figure out what it means. Results are often presented into a graph form. After the results are organized, we can draw a conclusion. The conclusion can be, my hypothesis was correct, or my hypothesis was incorrect. None of these conclusions should be seen as failures. Sometimes scientists learn more from an incorrect hypothesis than they do from a correct hypothesis. In any of these cases, the conclusion should also include a reason why you thought the hypothesis was correct or incorrect. If you have a possible explanation, you should also include that. So people who do similar experiments in the future can't understand why your results might have came out the way they did. Next, we have deductive reasoning. Deductive reasoning is a basic form of valid reasoning. Deductive reasoning or deduction starts out with a general statement or hypothesis and examines the possibilities to reach a specific logical conclusion. An example of deductive reasoning will be, all men are mortal, Harold is a man, therefore Harold is mortal. For deductive reasoning to be sound, the hypothesis must be correct. It is assumed that the premises, all men are mortal, and Harold is a man, are true. Therefore, the conclusion is logical and true. In deductive reasoning, if something is true of a class of things in general, it is also true for all the members of that specific class. Next, we have inductive reasoning. Inductive reasoning is the opposite of deductive reasoning. Inductive reasoning makes broad generalizations from specific observations. Basically, there is a data, then conclusions are drawn from the data. This is called inductive logic. An example of inductive logic is, the coin I pulled from the bag is a penny. That coin is a penny. A third coin from the bag is a penny. Therefore, all coins in the bag are pennies. Even if all the premises are true in a statement, inductive reasoning allows for the conclusion to be false. Here's an example. Harold is a grandfather. Harold is bald. Therefore, all grandfathers are bald. The conclusion does not follow logically from the statements. Next, we will look at how the hypothesis is different from a theory, which is different from a law. So a hypothesis is an educated guess based on observations. It's a prediction of cause and effect. Usually, a hypothesis can be supported or disproved through experimentation or more observations. A hypothesis can be disproven, but not proven to be true. An example of a hypothesis is, if you see no difference in the cleaning ability of various laundry detergents, you might hypothesize that cleaning effectiveness is not affected by which detergent you use. You can see this hypothesis can be disproven if a stain is removed by one detergent and not another. On the other hand, you cannot prove that the hypothesis, even if you never see a difference in the cleanliness of your clothes after trying 1,000 detergents, there might be only one you haven't tried that could be different. A scientific theory summarizes a hypothesis or a group of hypotheses that have been supported with repeated testing. A theory is valid as long as there is no evidence to dispute it. Therefore, theories can be disproven. If evidence accumulates to support a hypothesis, then the hypothesis can become accepted as a good explanation of a phenomenon. One definition of a theory is to say it's an accepted hypothesis. An example of this is it is known that on June 30th, 1908 in Siberia, there was an explosion equivalent to a detonation of about 15 million tons of TNT. Many hypotheses have been proposed of what caused the explosion, and it is theorized that the explosion was caused by a natural phenomenon and was not caused by man. A scientific law generalizes a body of observations. At the time it is made, no exceptions have been found to a law. Scientific laws explain things, but they do not describe them. One way to tell a law and a theory apart is to ask if the description gives you a means to explain why. The word law is used less and less in science, as many laws are only true under limited circumstances. An example of a law is consider Newton's law of gravity. Newton could use the law to predict the behavior of a dropped object, but he could not explain why it happened. As you can see, there is no proof or absolute truth in science. The closest way we get are facts, which are indisputable observations.